So to introduce the different types of standard solutions that we can use for titration, here you go. So we have actually two types of standard solution. So we refer to them as standard solution, and we have a primary standard or a secondary standard. So these are substances or chemicals that we use to prepare the standard solution. So what is the difference between a primary versus a secondary standard? The primary standard, it is a substance meeting a very strict criteria. So it's commercially available. So it includes a very high purity. So if you check the reagent bottles, they actually have, or they must be analytical grade reagents, and they have this on their bottle if it's, or in their certificate. So it must be uh, approximately 99%, or some of them 95 to 98. And then this indicates that it has a high purity. And the next criteria is that it must be stable. So it means that it doesn't react with air or other chemicals in the atmosphere. And it doesn't easily absorb water, which means that it must be non-hygroscopic. So we call this non-hygroscopic. And it must have a well-defined or known chemical formula or high molecular weight for it to be easy to weigh it accurately. And when do we use these primary standards? Because of its properties, we can use it to prepare a titrant with accurate concentration and get the accurate concentration of our standard solution, the titrant that we will be using for the titration. So this one, it's actually for standardizing the titrant that you will use in your titration. So what will we be using in the titration method is the secondary standard. And there are also various types of primary standards and secondary standards depending on the use and the reason that you will be using it. So we have here examples of the primary standard, which is in acid base, the most common one is the potassium hydrogen phthalate. You can also use anhydrous sodium carbonate, and for redox, we can use a potassium dichromate. So what's the importance of using this primary standards? So using this primary standards, it is actually very important for ensuring the accuracy because they provide a stable and highly pure reference substance with a known concentration, which allows them for accurate calibration of our standard solutions, the titrants that we will be using for the actual titration method. So why can we use this primary standard in comparison to the secondary standard? So our primary standards are based on its properties. They don't easily degrade or change in terms of their chemical composition because of their stability. So it's very reliable when you use it for calibration or knowing the concentration of your standard solution. So for our standard solution or the titrant, we actually use secondary standard. So for this one, the basic definition of a secondary standard, it's a solution or substance whose concentration is not known directly. So they are actually prepared by first standardizing them, or you need to titrate it against a primary standard, which is what we discussed earlier. So for example, you prepare a solution of sodium hydroxide to use as a titrant for acid-base titration, and you realize, so based on the property of sodium hydroxide, for example, this is generally true for secondary standards. So they have properties that includes that it has, or it is less pure and stable in comparison to primary standards, comparatively more reactive, and somewhat hygroscopic. So you realize if you are going to use a sodium hydroxide, which is classified as a secondary standard, so it's hygroscopic and it absorbs carbon dioxide, so it can degrade or change in its composition when you use it. So its concentration may not be exactly what you wanted it to be. So for example, you are going to prepare zero point 0.1 molarity, and then it turns out that it might not be zero point 0.1 molarity when you already prepared it. So aside from the aside from these properties, you can also take into account the possibility of the mistakes and error during the preparation of your solution. So that's why we can use these primary standards to verify the concentration of our secondary standard. And we use the secondary standard to prepare our titrants, and we can now use this to do routine titrations once the titrant is standardized. We also have examples of your secondary standards. So here we have examples, sodium hydroxide, potassium permanganate. So sodium hydroxide is commonly used in acid base, and potassium permanganate is commonly used in redox titrations. So why are these important? The secondary standards are very important in titration because they provide a more practical and cost-effective ways to perform this routine analysis, despite being less pure and stable in comparison to primary standards. So those are your